Welcome you to the next session of embedded software testing. In this session, we will go through some of the testing aspects and the setup configuration, and we will from this session we will look into some of the test names. What are the tests that is used? Test diagrams, test time, MCDC, test driver, other techniques. So then we will try to understand different types of testing, test format, test setup, basically what it constitutes. And we will go through each of the test setup mechanism, then the tools and how tools will be used in this. Okay. As I have briefed earlier in earlier session, different levels of testing basically categorized into 3 levels: the unit level testing, integration testing, system testing. I have not included acceptance testing because that is not the core in terms of the engineering deliverables. That is something like user level acceptance testing. So that could be a subset of any of these 3. Could be a subset of 1, 2, 3, or basically they use system testing outputs as a credit, and in addition they will take the sample and for business purpose they use. So in terms of core engineering and software testing activities, so these are the 3 levels of testing. In this diagram you can see different blocks. The same blocks have been rearranged for different types of testing. The first level of testing we will see component or unit testing. If there are suppose 12 modules in the embedded software, M1, M2, M3, M4 till M12. Each unit will have to be tested separately as a component. So whatever the interfaces that component has to do, or whatever the input it takes and produces the output, at that level we need to test it. Of course, there are subsystems which may have more subcomponents, like M4 may have M4.1, M4.2. You can combine that. It is up to the test strategy team how they want to define it. So, but in a nutshell, the basic modules we have identified and they will be used for component testing or unit testing. Coming to the next, integration testing. Here what we do, we take the same example of 12 modules for an embedded system. These 12 modules are logically grouped. Basically, it is based on the mostly based on the functionality of the feature set. This block 1, block 2, block 3, block 4. Here you see M12 as a single block. You may be wondering why M12 is tested here as well as here. The idea behind integration is this M12 could have a binding on hardware or any subsystem software. So that needs to be integrated. Why that needs to be integrated is we need to exercise that as a module, how it works with the other modules. How M12 can integrate with M8 and M9. How M12 can integrate with M10 and M11, etc. So going by this picture, there are 4 blocks. Each block is of interest. Other blocks will be tested separately. So all this integrated together, how it is behaving. That is what the scope of integration is. Next one is the system system. As I said earlier, all the blocks are put together in the box. If you consider these blocks as a one embedded system target. So that target will be basically fed into different uh, testing aspects, the signal or the IOs, whatever it is, will be put, and the output will be expected as a black box. Most of the realistic inputs will be fed into here, and that will be tested again. So that is the difference basically with integration. Here, I'll repeat. So component level or unit level testing, we do individual components or units tested separately. In integration, we combine several blocks or components together to test it on the software level, software to software or software to hardware. And in system testing, all blocks should be up and running in target, and that target will be provided with several inputs, and the expected results will be fed out as an output value, and that will be tested against those values. So all these three levels of testing is necessary. Why? Because we may not be able to test everything with the system testing. We may not be able to test everything with the integration testing. We may not be able to test with the individuals. That is not enough. So putting all this together, and that system testing we can say as a complete. You please don't get confused with the bottom of, top off, and all. That is all the approach or the method how it is done. Here, basically, given an embedded system, how we are going to test it, how we are going to break the main system into several modules, and how we are going to do it. So that is the philosophy behind the levels of testing. That is what we depicted. And if you suppose module 1 to one for the 1.4.2, 1.4.3, you can test it as a unit for all this and 1 to 1.4. So likewise for individual model. Here in this case, some feature or functionality include, or this block say block 1 integrated model will have a feature set feature 1, and block 2 might have a set of functions required for some other lead. That will be done. Synthesis, it will be used as a black box for the end target the end system is under wherein all the having all the features and functionality are put together, and accordingly the inputs, you can see the arrow mark or the inward arrow mark is inward, the inputs is a black box. The outward is for output. That is how this to carry out. Okay, just to highlight what we do, unit testing. Unit is the smallest testable piece of software. A unit can be compiled from the link loaded and put under a test array. I will explain what is test array in a later session. A unit under a test will be separately addressed for unit testing. Unit testing is done to show that the unit does not functional specification or its implemented structure does not match the intended design structure. This testing is done to satisfy the functional specification that is specific to that unit. So it is not satisfying that, or the structure what is implemented is not matching the intended structure. That is the goal of unit testing while under test to address all those things. Next is the integration testing. integration is the process of creating components to create larger components. As I said, the components are aggregated together to create larger components. So components could be M1 to M4, M5, M6, M7, M8, M9, etc. Could be one component as well. Integration testing done to that even the components are integration testing. What we do integration is the process of aggregating components to create larger components. As I said, smaller components are put together as blocks of 1, 2, 3, 4, whatever it is, M1, M2, M3, M4. These blocks are combined together, and we'll test against their interactions between the modules M1, M2, M3, M4 first. Then as a group or as a block, how it is interacting with other blocks like M5, M6, M7, or any other blocks of components. So that is the intention. Integration testing done to show that even though components were mutually satisfactory, the combination is incorrect or inconsistent. That means, as I said, you would have tested individually M4, M3, M7, M11, whatever it is, that may be working fine. But when you integrate M11 with M12, so what is the guarantee that it is working appropriately or correctly? So in order to do that, we will integrate it. So that is the purpose of integration testing. The combination should be correct and consistent. So that is the goal. The last one is the system testing. System is the big component. As I said, it's a black box. System testing is aimed at revealing bugs that cannot be attributed to a component as such, to inconsistencies between components or planned interactions between components. Still, you see, there could be some issues after putting together all these blocks. That means while first block is interacting with the second block, and while the third block or fourth block is interacting with the fifth block continuously within the system, there could be some issues, especially when you trigger some of the inputs or the signals. All together working should work correctly and consistently. So how do you bring up those issues? That is through the system testing. So system testing is aimed at revealing bugs that cannot be attributed to a component as such, to inconsistencies between components or planned interactions between components. Concerns, issues, behaviors that can only be exposed by testing the entire integrated system. So that is what the purpose of it, especially the performance, security, timing, recovery. These are some of the aspects will have issues when you test at a higher level. So the problem still is that sometimes it is difficult to isolate. Suppose I say the performance is not up to what is expected. Having with the entire system put under system testing, and I see there is a memory leak, I see there is a timing slack. I don't know where it is, the problem is. So how will you isolate? So that is one of the concern that we have at system testing. But of course, definitely this individual level, either at unit level or integration level, it may not be able to find out. How do we do it? So there are several mechanisms for doing that, either through debugging, where we do the white box sort of a mechanism. We connect the debugger and do a manual analysis using IDE, code inspection, or walkthrough, etc. So some of these issues, or you may use IDE tools such as profilers or time machines, etc. These are some of the alternates while doing the system testing, because some of the critical things may not be found out easily with the system testing. So there are alternates that we will use it. So that is about system testing. Of course, I said acceptance testing is uncovering the implied requirements aimed at evaluating fitness for use. It's a very selective level. That means some of these system testing tests can be reused to make sure that the product is accepted, and definitely that should not find bugs which should have been found in the earlier testing phases. That means integration and unit testing or system testing, these bugs should not be whatever the bugs are there, these bugs should be fixed. So acceptance testing is the last we do before we release the product. Okay, coming to test harness, the embedded system test harness. What it means? Web definition goes by like this: a collection of software and test data configured to test a program by running it under various conditions and monitoring its behavior and outputs. That means test harness will enable the tester to feed test data and test the program which is under subject by applying various conditions, and that harness should be able to support monitoring the output as well. So it's something like a test setup part of it. It's used for running groups of existing automatic scripts. That means once we have individual tests done, we should be able to run in a speedier way. That means we can group the existing tests in a batch sort of a mechanism where the environment or test harness will support. So the harness itself can be a tool for automated running of many scripts. Like we, as I said, we can create batches of scripts, and that batch can be run on the harness in a consistent and continuous manner, so that the testing will be speedier, and a lot of automation is involved here. Fetching of scripts and test data. What it does, the automated running of batches is fetching of scripts and test data. Any actions or failures should report as a failure or report the log, etc. And test and defect metrics or management, like how many number of passes are there, how much it has failed, like in terms of overall automated batch output, this will take care. So that is nothing but the test harness. The test harness could involve many things such as invoking a simulator or emulator, or test drivers could be involved as well. So there is a difference from test running tool and test harness. So test running tool is something like a underneath piece of activity. Test harness is above that, which will help in terms of automating and running at a higher level. See, typically test harness is like a super test running tool. The other name used is super test running tool. So controlling perhaps a few test running tools. I mean, some other sub tools it can control or trigger or drive it. So test harness can be used to run groups of existing automated test scripts. Its typical activities are fetching, as I said, scripts and test data. Should take actions for failures and should be able to manage the tests like reporting incident reports, defects, pass fail criteria, outputs, and all that will be part of this. So that is about test harness, because this is one of the important elements that will be used across all this. Test harness is very much needed for unit level testing, integration testing, system testing. So test harness will have its own set of setups for each of these. Okay, so coming to the next slide, this is about test setup. We know that test harness is required. Underneath that, what are the things that we need to take care? Embedded software testing test setup. There are several ways the test setup can be done. It again depends on what level the system is required. I will explain typical how it is used. Basically, host and target test systems during development process. That is one thing they use it. That means during development again, the developers have to have a confidence on what they develop. So they will have a set of host and target interactions. The same thing can be used for testing also. So we know that host and target what it means. Earlier we have discussed two systems will be there. Hosts will have x86 or whatever it is. CPUs will be there, and target will be having its own architecture or microcontroller based target system will be there. So one system host, generally PC or laptop or workstation will be used. Other system will have a target or the actual hardware. Actual hardware can be a microcontroller based or microcontroller plus any other hardware like FPGA or any flash device, anything could be, which is used under the development. So continuation of that, host and target independent and target dependent code. So what it means, like there are a few code like hardware related, suppose take microcontroller related or registers which we may use. For example, target specific hardware registers, microcontroller registers, memory, etc. Those all are called target dependent. Target independent, say that is this left. Target independent is something like we have algorithms, few utilities like conversion utilities, any flow structure, data structure mechanism, etc. These are all target independent. That means you don't have a dependency on the target for this piece of software to run. So that is how they categorize it. So same thing is explained here. code has two parts: hardware independent and hardware dependent code. And port is nothing but a piece of interface which is residing in the target. And devices, like as I said, it could be flash device or any crystal or anything that will have access with the microcontroller using a address. So that addresses are fixed, so we cannot use it as a generic. So this is one of the setup that is used. That means host and target based systems. The same thing will be used for development as well as same thing will be used for testing. So some details about host, testing and debugging at each stage as well as at the final stage when the models are put together. That means this will be fixed. The different stages of developing and integrating onto the target with the help of host will be done at the same manner in different stages. So testing can be done at initial stages at the host side. That means having developed some piece of software, we can use the same host for testing it, like whether it is working as expected or not. And in the host itself, we can use, like, we don't need to program that onto the target. As I said, there are independent software code that can be used in the host itself, wherein those modules like algorithms and those things can be run and tested on the host or the PC. Also, there are integrated development environment target based systems which will allow for user to simulate. That means that simulator is an application which will be running on the host, which can simulate the target that is intended to be used. We will touch base each of these things in detail in the next class. So this is the definition about target. So this is used to test hardware independent codes. So I think there is a mistake here. It should be hardware dependent codes. And the target is also used to run monitor. That means from the target, anything that we expect to see the output of the test. So we'll need some monitoring mechanism. So that monitoring mechanism can be hooked into a target. That is how the target is used. Here is a typical diagram of a host and a target, how it is connected. So typically this is used for development. Some of this can definitely be used in a testing also. Like in a testing, we may have to develop some scripts which will use the same interface for testing onto the target system, and the scripts will have a dependency on the probe or the test or the development environment hook, which will be used for debugging the target system. And I'll brief about this host and target systems during development stage. There is a laptop or desktop which will have an interface with the target system with the help of an IDE. IDE generally uses probes which will probe the registers or the memory and all that hardware related information through a probe box that is called JTAG. And there are tools which will interact with this and will allow the user to monitor or put values and all that. So for example, IDE integrated development environment, we have is a GHS, Green Hills Society, Code Warrior, etc. And the interface with the JTAG will be usually through USB or Ethernet. Now, as I said in the earlier slide, how the target system will be used for testing. So once we have the development done, we no more require any of the IDE or JTAG which is connected to the target system. In lieu of that, what we will use is the target system actually connected with the real inputs, that is realistic values. with the help of test panel or breakout box that can be used to provide the inputs. And to test the values, we monitor the values. We use interfaces such as CAN, Ethernet, or it could be RS-232 also. I have seen a separate system connected to target system. I mean separate interface as well. Some of the monitoring can be done with the help of that. For example, RS-232, and that all can be segregated in the host with the help of something like testing tools. Those testing tools will help user identifying the failures or run scripts and batches, etc. Okay, so we know that there is a target system, how it can be set up with the help of this. There are different mechanisms that can be used for doing the test setup. There are broadly three categories. Having said that, we use different test setups for development and testing. The test setup is broadly categorized in three ways: testing with simulation, testing with emulation, and with the help of target monitoring. That means the target debugging testing is classified as simulation, emulation, and target monitoring. What are those? So we will see each one. So target, the embedded system target can be tested with the help of simulator. So in simulation, what it does basically is it uses the knowledge of target processor or the microcontroller and target system architecture at the host side. That means on the host processor. It means we have seen the host is the desktop or the user station or the laptop. So all the information that is required from the target side will be available in a simulation manner. So we don't need the target should be running, but the host has a knowledge. So for that, what we need to do is first the developed code or the code that we have should be compiled, cross compiled. I think I have explained what is cross compilation and embedded C. Anyway, that is part of the embedded system basics. We use cross compiler where we have the code developed in the host and compiled for the target. So that is cross compilation. So what we do is we do the cross compilation of the code and place it in the host system RAM. That means host system will have the compiled code. Then behavior of the target system processor registers are all simulated with this simulator. It uses the linker and locator to port the cross compiled codes in RAM and functions like the code that would have run at the actual target system. That means it's as if the target is running, but it will be running in the host with the knowledge of whatever the target it is having in the host. So few bullets: code tested for the MCU system by simulating it on a host computer used for code development. Simulates the hardware units like emulator, peripherals, network, input output devices on the host or the workstation. It means all the peripherals that it has, it tries to use it, tries to emulate it basically with the help of whatever the emulation characteristics that has. The simulator remains independent of a particular target system. As I said, so it doesn't have a dependency on the target. The results expected from codes at the target system RAM, peripherals, network, or input output devices are obtained at the host system RAM. I would say it may not be 100% possible with all these devices and the peripherals, but At least the generic nature of all these memory peripherals and all that should be able to simulate. So that is how they have developed the simulator. It provides the detailed information of the status of peripheral devices like uh, it's a rise, running or stop, etc. with the defined system. Provides the detailed information of the steps as the execution goes on for each single step or each single module. I think one session I will have in terms of debugging testing with the help of IDE, integrated development environment. I think it will be probably more clear with that. How do we do it? And similar manner simulation also will be used. It is not too much away from what we usually use in the debugging environment. Instead of the target system, the host will have a simulation based system. It also supports all the breakpoints like conditional, unconditional breakpoints, etc. These are all some of the simulation breakpoints or the software breakpoints we use for simulator. So the advantage is this helps in the development of the system before the final target system is ready with the help of only a PC as a tool for development. That means we don't need to actual target system. At least we can progress some development or testing before we actually get the target. In general, in industry, what will happen is I think I will explain this in model. I mean, different models that is used. The hardware and software planning requirements and development goes parallelly. Hardware is bit ahead of software. Hardware should be ready, but what will happen is it is likely that before the hardware or the actual target is ready, the software piece would have been developed. So get the confidence of what is being developed. So we use mechanisms such as simulator, etc. So that will be of very much use and it helps for the initial development stage. And simulators are available for different processors and processing devices which are targeted for embedded systems. So most of the processors or the microcontrollers that they develop, definitely there are simulators available. Most of them, like you take microcontrollers such as TI based or Motorola based or ARM, whatever it is, they will have simulators we can use for simulation. The same simulator can be used for PDR testing, especially the same code we can build the target and that code can be tested. Especially for unit testing, this will be useful, where we use individual modules and those modules can be simulated if possible. Like as I said, algorithms or software flow states, etc. can be definitely tested with the help of simulator, if not all. So, but simulator will have some disadvantages. Those are timing and the speed issues can't be resolved. As I said, the actual timing of the microcontroller or the processor with the actual load of the signals or with the actual peripherals or devices connected. So definitely will vary than whatever we use in simulation. So those issues we may not be able to test completely because the calculation of process speed and the host will not be adequately mapped. We may map one piece or one processor or one peripheral, but all cannot be synced easily with the help of simulator. And of course, as I said, hardware dependent testing, like we have some of the baud rate or the interfaces connected for SPI or SPI interfaces, we may not be able to test it. And of course, we have developed the code in the host environment and cross compiled and done it simulation, and they should be able to port it as it is on the target without difficulty. But since there are some issues, especially on the bindingness or accessing the memory or big Indian, little Indian format issues, Definitely there are a few things which has a simulator lacks. That is about simulator, and we go to emulation next. So that is the next technique which will actually use the end target. One thing I remember in terms of simulator disadvantage is that, for example, target system may have 8-bit data bus between RAM and uh, unpipelined or memory mapped processor, and host may be having a pipelined processor, and it could be a 32-bit. So there is a difference with the target system and the host. Similarly, simulator may fail to show a bug from shared data, as it arises from an interrupt in some particular situation only. So like you may be aware of the interrupt. Some interrupts can come at a real time. The simulator we may not be able to do. So these are some of the disadvantages which I think that we cannot use a simulator. We should definitely use the next techniques. It is emulation. So what is an emulator? It is also called as an in-circuit emulator. So basically, which actually takes the in-circuit values and will provide the user a gist of what are the values that is going on with the target. So which will actually emulate what is needed. Similarly, user can put the values into that registers with the help of emulators. So emulator is also known as in-circuit emulator, ICE. Circuit for emulating target system remains independent of a particular target system and processor. Emulator or ICE provides great flexibility and ease for developing various applications on a single system in place of testing that multiple target system. That means we have a batch of different target systems, but many of the components are same, and we can use an emulator on one system, and probably it will ease out for developing different applications on different target systems. Suppose some sensors are connected to the MCU that can be emulated. Emulates controlled outputs for the peripheral interfaces systems. That means we actually use the peripherals or interfaces which can be triggered or which can be controlled with the help of emulator. Emulator emulates target MCU outputs and socket to connect to externally MCU. Suppose one more MCU or other MCU is used, so we can have multiple emulator or the single emulator connected with the first MCU, and it can be hooked or socketed with the other MCU, because there are complex systems where we have multiple microcontrollers, so both have to be used, and both will have some interface, some inputs and outputs. So how do we do it? Definitely this is not possible with the help of simulator. We have to use the emulation technique. So what emulator does is we compiled for the target, and it produces the object files. Those object files and the binary or the image for the microcontrollers which is required will be used by the emulator. It uses the debugger at the computer developed files for the MCU application. That means there is a debugger. That debugger will have a knowledge of the entire MCU, and MCU corresponding applications can be debugged with the help of the emulator. This emulator, why it has come for testing, you may ask, because emulator is definitely used for development. It can also be used for, more or less it is used for testing also, because some of the testing may not be possible with the help of automated way or as a black box without the with the target not having connected with the development environment. Why? Because some of the intricacies within the target system need to be inspected with the help of code. So user tester has to go through the test code or the code on the target. So how does he do is with the help of emulation. So emulation, that is why it used for testing also. That is why we have taken up this as the one of the technique in terms of target debugging and testing. The next one is target monitoring. So what is monitoring? Monitoring is an output activity from the target system used for embedded system testing. So what are the elements basically? Monitoring is a resident program of the target based system which is connected with the host. As I said, the connection could be RS-232 or any of the interfaces. The interface could be RS-232. Generally they use, or CAN also is used in many places. Control area network. So for this, I think we definitely need some program which is residing in the target system, because that has to interface with RS-232 and it has to pump in some data to the host, and the host has to acknowledge, and host can request the target system also. For that it has to respond. So there is a handshake involved for the between the target system and the host. For that, a dedicated monitoring application is needed at the both side, host side as well as on the target. Monitoring monitors the target system events and data and communicates them to the PC. As I said, it uses the interface and comes in the data to the target. The computer interface commands command the interpreter. That means for retrieving the data or analyzing data, it may have to send some commands and respond for the data. So it uses some commands. There is a protocol or the handshake involved between the target board and the host. Generally, the commands are read and write. Mostly they are used for memory registers operations. And also there are systems which uses the same interface for downloading the target application. That is the image, the binary onto the target can be downloaded with the help of PC. So these are some of the target based debugging or testing mechanisms with the help of test setup. Test setups we have seen how it will be. Next one is the tools. So we will conclude this session with the tools, with tools list example, and in the end we will touch base a few embedded system testing words. So it's like something like a recap of what we have studied so far or what we would like to study. So these are some of the words that has to be a part of a tester. He should be knowledgeable enough anytime to talk on this jargons. Okay, so embedded system testing has to have a list of tools, and there should be a well documented tools list with additional information of the tools usage guidelines, etc. And all these tools should be referred or mapped in the test plan. We have seen how the test plan looks like, and that should have a reference to all those tools or a tools document. and that should be controlled or configured with the help of configuration management. And any change over the period of testing or development or the entire life cycle definitely will have an impact. Why it has an impact? Because whatever we intended to use, whatever we want to develop scripts or tests on one version of tool may not work on the next version. So that is for example. So similarly, any checklist or guidelines part of this usage of the tool, any changes happens that has to be controlled. So any deviations that has to be taken care with the help of deviation process along with the impact. So definitely there is an impact on the whole test cycle. Wherever there is an impact, that needs to be mitigated. So embedded software testing tools, will go through an example how it is listed. I need to share this. This you can use a template as what we did in the earlier stages like test plan and procedures cases. I have not put the template probably as one of the exercises we can have all these tools. There is an example I have put it here. Maybe there is an exercise we can take it up during the practical session to list out all the tools and its usage as part of the template. So the template looks like something like the tool information, the tool name, when and how to use, who is the author, and of course we can have a tool version as part of this only, or configuration information also can be. So this is a template that generally they use for tools, and I have for this course planning to use some of the tools listed below. It depends on the availability and other things, and as an example I have listed out here below. Typically target based system, as I said, will have a 8-bit, 16-bit or 32-bit microcontroller. Along with that we should have an ID development environment for compiling, debugging and testing the developed software. For that we use evaluation boards. We can target to use a 8051 based or ARM6 or 7 or 9 based DVBs. These are all available in the market. We can use it for testing. Once we have this target based system, we need to have the requirements as an input. That is anyway part of this phase. So we will develop the test case and we will do the test case design, documentation and reporting. This can be with the help of documentation. Microsoft Word or Excel can be used. Once we lay out the test procedures, we need to have a scripting mechanism. Scripting can be done with the help of Python or Perl. I'm not sure how many of you are aware of this. This is near to any other scripting tool. Like you can take, for example, shell scripting in Linux or DOS in Windows. So that also will have command line arguments and all that. So this can be used for scripting, and this is an open source. You can always download and use it. And for testing, we know that we have to use static analysis, reviews, and all that. For that, one recommended tool is understand from Sky Tools. This also there is an evaluation they give it actually. This is a good tool. Why? Because it gives up a complete code picture or something like a call tree and all that it produces. It also gives a configuration output how the code is organized in terms of data code. We can apply the rules, the coding rules, and we can see many of the uh, other aspects like complexity. Of course, it is called software complexity. I will, I think one of the session I will explain what is software complexity. It's basically how complex the target system is about. It tells the number basically. For any embedded system in the industry, there has to be some limit on the complexity. Beyond that, it cannot be uh, developed. So we use that understand plus C++ for static analysis. For test defect management, we use a tool called TestLink. For testing, we use TestLink. It manages all the test cases, procedures, test suite also, and of course the scripts also we can link it with the help of this testing tool. It doesn't test, but it helps us to manage. That is called TestLink. Similarly, once we have tested with the help of this test case procedures and all that, we can link them the pass fail result or reports. Like failures can be controlled. I mean, can be managed with the help of defect management tool called Bugzilla. It's one of the open source good tool. Of course, this TestLink is also a open source tool, and we can use for same TestLink and Bugzilla for configuration control also. That means we know changes will happen, versioning is to be there, etc. All this can be taken care with the help of this TestLink and Bugzilla. It itself has a flavor of configuration. So this is an example of test tool. So that is about tools. Okay, so in this session we have gone through different levels of testing, component or unit integration system. What is unit testing? What is integration testing? What is system testing? Test harness, what it means. Setup, a typical embedded software testing setup, how it will be. In specific host and target based system, how it will be developed or how it will be used. Is a development test setup, is a real environment testing setup, and how we can test. Having said that, all this environment is available with the help of three techniques: simulation based, target based monitoring. So simulation use the target based knowledge available in the host, and all the um, interfaces and the processor can be simulated at the host. And we know that always a simulator cannot be used. That has disadvantages in terms of hardware dependency. In those cases, we use emulation, which will actually use the in-circuit emulation technique in terms of bringing up all the hardware values into the host. With the help of host, we'll write, read, and all that values into the target. And the same target can also be used for programming the multiple object files or different programs. The next technique is the target monitoring, where there is a already built program running on the target, which will have an interface with the host, and there are commands for read and write with the help of which the target is interacted. And the setup has to be configured and controlled. with the help of software environment configuration. It is called environment configuration index, which will list out all the tools, what is the environment you completely. This should be mapped with the test plan. And embedded software tools, we have seen an example. So what are the tools and what are the information that should be used for listing out and how to use it, and any changes over the period of testing has to be taken as a deviation. Okay, so I have listed out some of the testing words. Probably the next exercise will be to put at least a single word definition for this. So my next exercise or question is something like, okay, so it means put a one sentence answer for some of the words which we have gone through in this course. Test harness. What is test harness? You can put one line definition or put a small paragraph. Test bed. Test bed and test bench both are same. It is used in different context. In some industry they use as test bed. Some industry they use as a test bench. And the actual environment that is used will have something named something like automated test equipment (ATE). And of course this we are not done. Model based testing we will touch base in the next class. I have listed out all the words. So what are the words that we have gone through? You can put one sentence answer. Test stubs I think we have not seen. Test driver we have not seen. Fault injection is nothing but error injection or fault triggering. We have MCDC that will be covered under unit testing in the later stage. Test hook, we know that test hooks will be used for testing the target system, where the hooks will accept the user inputs and provides user monitoring mechanism. Boot software, boot up program, bootloader, which will help in loading the new application. IO is a input output, ICT is a interface control document. Basically in embedded industry they use this document primarily to define the interfaces. This is a separate requirement document sort of a thing. This will define all the inputs and outputs for the system as well as the requirements. We know what is breakpoint, we know what is simulator, what is emulator. Trace, I think this is part of the emulation or emulator. You can define what is trace. Profile for profiling some of the memory and all, we can use it. And for target processor we use a datasheet. Datasheet is used for as a reference manual from microcontroller such as ARM, 7, etc. So this is one of the need that embedded system tester has to have. Why? Because he needs to have a knowledge of the microcontroller which is under test, and every microcontroller will have a errata or it is a erroneous information which will explain about any of the bugs or errors. Still it is available in the microcontroller which user should be aware of. We know what is ICE in circuit emulator. The question is please provide an one-line answer for some of the words that we have used in this course. So that's all about today's course, and next time we will touch base on the next session.